All right, number 3, we want to find all the zeros of this polynomial function, and we want to list the multiplicity. So that's kind of like what we saw in the first problem. Some of them were squared or to the third power. So it says be sure to find all the appropriate number solutions counting multiplicity using linear factors. So when it says using linear factors, that means we're going to take those zeros and we're going to list them as either x plus or minus some number. Okay, we're going to list them all like this, and if it happens more than one time, then we'll have a number up here for my exponent. That will be the multiplicity. Okay, so this is a big polynomial. Normally what we do is at rational root theorem, try to figure out what zeros there are. However, just to save you some time, we really want to work on you finding the zeros and listing them in linear functions. We're going to graph this, okay? So I'm going to go to y equal, I'm going to clear out anything which is empty, and I'm going to type this polynomial in just as it is. So x is here next to the alpha, so you do x, and then I'm going to raise it to the 5th power. So right below the clear button, this thing that looks like a housetop, that's how you do an exponent. This older calculator doesn't actually put it as an exponent, but this is doing the same thing. And then we have to subtract x raised to the 4th, and then we add 15x, and we could do third. I'll show you how to do that one. If you go to math, option number 3 has that exponent. That's not what we want. Delete that. We go math, and then number 3. Okay. So that gives you a cube. It shows it just like an exponent. And then minus 15x, and then we have a squared button, and then minus 16x, and then plus 16. So we got it all typed in. Now I'm graphing it just to look at the x-axis to see approximately where it crosses. Okay, so we can see, let me zoom in. Zoom number 2. Hit enter, it's going to zoom in the middle. So this is 0, -1. So it looks like if I trace, let me type in the number 1. I like the graph. Let me do trace, and then I'm going to type in the number 1 and hit enter. Hey, so here's 1. It looks like it touches at 1. So 1 is one of those double roots, so it's like a square. And then over here, this looks like -1. So I'm going to go, I'm going to type in -1. You have to hit the trace button to allow you to input. Otherwise, it kicks you out. And it says error, because I put -1 instead of -1. Okay, so let me try this again. Trace. You have to hit the negative at the bottom, not the minus. And then it will do it. So this one looks like it happens at -1. So I at least got 2 zeros, -1 and +1. And from there, I'm going to do synthetic division and keep breaking this down until I find the other zeros. Okay. So I'm using the calculator to at least show me some of them. Okay, so here's my polynomial function. Put this over a little bit. We have x to the 5th minus x to the 4th plus 15 x cubed minus 15x squared minus 16x and then plus 16. Okay, so we know that -1 and +1 work, and +1 should work twice because of what we saw on the graph. Okay, so I just wrote down -1 and I wrote down +1 twice. I'm going to try those with synthetic, and we should end up with 0 each time. And then from there, my remaining polynomial, I'm going to factor or do quadratic formula. So, listing my coefficients, we have 1, -1, 15, -15, -16, and 16. And the first number I'm going to use is -1. It's going to be in my box. Okay. And we're going to do synthetic division. So you bring your first term straight down, and we multiply. -1 times 1 gives you a negative 1, and you combine these two, we get a negative 2. And then you multiply again, negative 1 times negative 2 is positive 2. Negative times a negative is positive. Both positive you add, we get 17. Negative 1 times 17 gives me a negative 17. Combine these, and we get negative 32. Negative 1 times negative 32 gives me a positive 32. And we subtract because different signs, and we get a positive 16. And then negative 1 times 16 gives me a negative 16. And then combine these, we get 0. So if it is a 0, the last term should be 0, which it is. Okay. So negative 1 is a 0. So basically what we're saying, let me go over here because we want to write it as linear terms. X equals negative 1 is a 0. Set this term equal to 0 by adding 1 to both sides. And we get that x plus 1 is one of the linear factors that we're going to be listing. Okay, now we can continue from here. So our polynomial started with the 5th degree. These are the coefficients. This will start with a 4th degree. So I'm going to say x to the 4th. But I'm going to continue dividing. Now I'm going to use the number 1. Because from the calculator I saw that 1 should work, and it should work twice. So I'm going to continue from here. Bring the first term straight down. And you can only do this if you end up with a 0. You can continue going. So 1 times 1 is 1. Combine these two, we get a negative 1. 1 times negative 1 is negative 1. Combine these two, we get positive 16. 1 times 16 is 16. Combine these two, we get a negative 16. And then 1 times negative 16 is negative 16. Combined, we get a 0. Okay, so again, we end up with a 0, so that does mean 1 works. So this will be x to the 3rd power, because each time we do this, we're going down 1. Sorry, I don't know if you couldn't see all that. I was working it out. So 1 is a factor. So again, let me scoot over. So that's saying x equals 1 is one of my linear factors. If I solve and set it equal to 0, subtract 1 from both sides, we get x minus 1 is a linear factor. So we have x plus 1, x minus 1. Okay. And since we saw on the calculator that 1 works twice, we're going to try 1 again, okay, because it was a double root. And so bring the first term straight down. And 1 times 1 is 1. Combine, we get a 0. 1 times 0 is 0. Combine, we get 16. 1 times 16 is 16. Combine these, and we get 0. So we end up with a 0. So 1 works again. So over here by this x minus 1, we're going to put a squared above it. So that's multiplicity 2. That's what they mean when they say multiplicity. You get the multiple 0. Now, we had x to the 5th degree starting out. When we divided out one term, we ended up with the 4th degree. We divided out another term, 3rd. Divided out another term. Now we ended up with a 2nd degree. So these are my coefficients. This is x to the 2nd. So this first term is 1x to the 2nd minus 0x, and then since that's positive, plus 16. So here is my remaining polynomial, which it just simplifies to x squared plus 16. And from here, we set this equal to 0 and we solve. So if I subtract 16, we get x squared equals negative 16. And then if I do the square root of both sides, to solve for x, we get x. When you do square root, you have to remember plus or minus, because it could have been positive or negative. We can't take the square root of a negative, so we pull that out as an I, and then we have square root of 16. And then we can do square root of 16, that's 4. So we have x is equal to positive or negative 4i. So my other two zeros are positive 4i and negative 4i. So when I write those as linear terms, we end up with x minus 4i and x plus 4i. So here are all of my linear terms. X plus 1, x minus 1 squared, x minus 4i, x plus 4i. This is what we're going to type in our blank here. So in parentheses, we'll do each term, and its order doesn't matter. So I guess, I don't know. says use linear terms, but I wasn't able to put in parentheses. Let me see if I can put an X in there. Nope. So I guess I'm just going to list the numbers. We found out that -1 worked, and I'm going to list it twice, 1 and 1, because I say list the multiplicity. And then we also had 4i and then -4i. Okay. So it said linear factors up here, so I was thinking that we wanted to write it like this, but it's not letting me put parentheses or X, so we're going to try this. And it's good. So just make sure you list everything multiple times if it repeats from what you see.